Let's explore what electric current is and see how we can calculate it. So we'll start with the word current. Current is a measure of how much something flows per second. So let's write that down. It's a measure of how much something, it can be anything, and we'll take examples, something flows per second. So for example, if we were to calculate how much water flows per second in a pipe at some point, that would be water current. If we were to find how much air flows per second, say in a tunnel at some point, that would be air current. But for electric current, we calculate how much charge flows per second. How much charge flows per second through, say, a wire at any point. So let's take some examples. So imagine we have a metallic wire over here. And the specialty of metallic wires is they have a lot of electrons inside them which are free to move around. Lots and lots of electrons free to move around. And so if we push these electrons, then these electrons can flow. And we'll see in future videos how we can push the electrons. But once the electrons start flowing, we have charge flowing because electrons are charged particles. And so when electrons are flowing, we have a current. And so now let's say you stand over here and somehow calculate how much charge is flowing through this point. Let's say you concentrate on this point of the wire and you calculate how much charge is flowing through this point. And let's say you measure and you find out that there are 10 coulombs of charge. 10 coulombs of charge flows through that point in 5 seconds. In 5 seconds. So what's going to be the current at that point? Well, the current, which we usually represent as I, we need to calculate how much charge flows per second. So how many coulombs are flowing per second? So right now we have 10 coulombs per 5 seconds. So that amounts to 5 goes 2 times, we get 2 coulombs per second. And we can now say that is the current at that point, 2 coulombs per second, which means every second 2 coulombs are passing by. Let's take another example. Let's say, again, you take a different wire, different current, and now you find out 3 coulombs flows in 6 seconds. 6 seconds. Can you calculate what the current is going to be over here? Pause the video and see if you can try this yourself first. All right. Now the current I is going to be, we have 3 coulombs per 6 seconds. And 3 divided by 6 is 1/2. And so you get half. So the current over here is half coulombs per second. And that's how you calculate current. So let's generalize this. Let's see if we can come up with a general formula to calculate the current. In general, if we find, let's say, Q amount of charge flows in T amount of seconds, then we can now write current in general is going to be the amount of charge Q divided by the time for which you waited, divided by T. And if you look carefully, that's what we did in both the cases. We divided the charge by time. And that's how you calculate the current in general. And so the unit for current is coulombs per second. And coulombs per second is often called amperes. Amperes, which we write capital A in short. And this is named after this French scientist André Ampere, who did a lot of work on this in electricity. So over here, we could say this current is 2 amperes. Amperes just means coulombs per second. So over here also we could say this is 0.5 amperes. We'll just take one more example so that we are super clear with this. So let's go down a little bit. So let's say we have a current, somebody says we have a current of 3 amperes. What does it mean? Well, it means there are 3 coulombs of charge passing every second. Now, can you calculate how much charge passes in 5 seconds? So if you wait for 5 seconds, how many charge would have passed through that point? Pause the video and see if you can try this yourself. All right, let's see. We already know that 3 coulombs are passing every second. Since we want to calculate in 5 seconds how many charges passes, we just multiply this by 5. 5 seconds. Second cancels, and we get 15 coulombs. 15 coulombs. Or you could have also used this formula. It's the same thing. Notice we are multiplying the current with time. So if you multiply the current with time, you get the charge. One last thing we can talk about is the direction of the electric current. So let's say all the electrons over here, for example, are flowing to the right. And I ask you, what direction is the electric current? You may say, intuitively, it's to the right, because all the electrons are flowing to the right. But it turns out it's the opposite. The direction of the electric current we chose is the opposite direction of the flow of electrons. And you may be wondering, why did we do that? Well, the main reason for this is because electrons are negatively charged particles. You see, when we assigned the direction of the electric current, we had no idea about electrons and protons and everything. It was way before we discovered them. We just thought there is some kind of positive charge that is moving in a wire, and that's what's giving us current. And therefore, we chose the convention for the current as the direction of flow of positive charges. And because electrons turn out to be negatively charged particles, we have no option now. We have to choose the convention to be in the opposite direction of electrons. So if the flow is of positive charges, the current will be in the same direction. If the flow is of negative charges, the current will be in the opposite direction. Since electrons are negatively charged particle, the current direction we choose is in the opposite direction. So to quickly summarize what we learned, electric current is how much charge flows per second through any wire at a given point. We saw how to calculate the electric current. We saw its units are coulombs per second, which is also called amperes. And finally, we saw that the direction of the current that we choose is the direction in which a positive charge moves. Now, because in all the wires, which are metals, it's always the electrons that are going to move, and electrons are negatively charged particles. Almost in all the electric circuits and wires that we'll be dealing with, the direction of the current is always going to be in the opposite direction of the flow of the electrons.